Hello everyone, myself Pansas Srinivas. I am from CSIDB section. My role number is C7. My topic is about generative adversarial networks in data augmentation. Before going to the topic, introduction to the data augmentation. Data augmentation involves creating additional data samples to enhance the model training. It is especially useful when limited labeled data is available. Techniques range from simple transformations to advanced generative methods like GANs or something like Vans Slants. This is about the data augmentation introduction. And what are the generative adversarial networks? Means GANs. GANs are the class of deep learning models, consist of two neural networks. They are trained together through an adversarial process to generate the realistic data. GANs have revolutionized the field of synthetic data generation in recent years. Components of GAN. The greater creates synthetic data that mimics real data distributions. The discriminator evaluates whether the data samples are real or generated. Both networks are trained simultaneously to improve the quality of generated data, means synthetic data or real data. How GAN works? The generator produces a fake data aiming to aim fool the discriminated. The discriminator learns to distinguish real from the fake data. Training continues until the generator produces high realistic data that discriminator cannot easily identify. Advantages of GANs in data augmentation. GANs can generate diverse and complex data samples. They help balance data sets with class imbalance issues. Synthetic data from GANs can improve the robustness of machine learning models which are generated at the past. And the applications of GANs in data augmentation is image synthesis or creating realistic speech, audio, or augmentation of text datasets. In image synthesis, medical images and object recognitions are used for generating the data augmentation. And realistic speech or audio data, it is used for speech recognition systems, and in augmentation text datasets for natural language processing tasks. And GANs in medical augmentations. GANs helps to generate synthetic medical images for rare disease datasets like skin disease, brain tumors, or extra MRI scans. They assist in increasing training data without patient privacy concerns. This improves the accuracy of diagnostic models in healthcare sector. GANs for image data segmentation augmentation. GANs can produce high resolution images for computer vision tasks. They help mitigate overfitting by providing additional training samples, by removing the noise or fitting the grids with the perfect sizes. In synthetic images can be used to improve the object detection and classification. Challenges of using GANs for data augmentation. Training GANs can be unstable or tricky to tune. Generated data may contain artifacts or unrealistic data features. Ensuring diversity and quality of the synthetic data remains a challenge for the users or a developer to develop an trained model. Techniques to improve the GAN power performance. Uses of advanced architectures like progressive growing GANs or incorporating loss functions such as westernizing loss for stability, applying the regularization techniques to prevent model classes collapse, not classes. And for evaluating the GAN generated data, we take the visual inspect as an common but subjective method. Quantitative metrics like inspection score, a z-score, or French and inspection distance are used. Human expert validation is also important for critical applications, for cross-checking or for any error bugs which are caused by the system to resolve them. Ethical considerations. Synthetic data must not be used to deceive or manipulate, which means synthetic data in sense of which have multiple data values which can cause deviations in a model of training, and privacy concerns also alleviated by generating data without real patient info, and responsible use of GANs involves transparency and adherence to ethical standards. Future trends in GAN based data augmentation. Integration with other AI techniques like transform learning, development of a more stable and efficient GAN architecture, and expansion into multimodal data generation, combining images, text, and audios. Expansion into multimodal data generation, combining images, text, and audios. Case study of GANs in medical imaging. GANs have been used in generating MRIs, CT scans for images. These synthetic images help train better diagnostic algorithms, results in shows of significant improvements in detection accuracy and model generalization. And case study of gangs in autonomous vehicles. Synthetic data generated for rare driving scenarios helps to improve object detection in diverse environmental conditions, enhances the safety and reliability of autonomous driving systems, which are used for autopilot, and the limitations and risks of GANs in data augmentation. Over reliance on synthetic data can lead to overfitting on artificial patterns, potential for generating bias or unrepresentative data, need for careful validation and data expertise in data generation. Best practices for using GANs in data augmentation. Combine synthetic data with real data for balancing training, which is like real image and mask image, and we can both compare that to generate an output image which is a segmented image, and regularly evaluate the quality and diversity of the generated samples. Use domain knowledge to guide the generation process and validation. Then, moving on to the conclusion, GANs are powerful tools for enhancing datasets in various domains. They enable the creation of realistic, diverse, and high quality synthetic data. Proper implementation and validation are critical for successful data augmentation, which helps in furthermost evaluating terms. And summary of key takeaways: GANs improves data availability and model performance through synthetic data. Challenges include training stability, quality control, and ethical considerations. Future advancements like will likely expand their applications and effectiveness. Thank you. Thank you for giving this wonderful opportunity. This is about the GANs in data augmentation.